go through the naming. Number B2 is going to be B2, right? Let's try to quickly go through it and see what's up. All right, so I'm going to say we're going through B2 now. Number A says, make drawings. Okay, it's not saying, oh, naming, it's saying make drawings of the following molecules. And you see, look at what they give us, IUPAC. So you need to know the IUPAC names or the common names. Both of them, either of them can come. So now let's see. I'm going to increase my font size a little bit. Okay. Put it to 10. All right, so now let's see. Okay, yeah, it's better. Now I have 5 isopropyl. So I want you guys to understand that propyl is 2. It is N-propyl, which is the normal one, which you just see being written as propyl. Remember, propyl, you'll be having 3 carbons, right? 3 carbons bonded together, and these 3 carbons are part of are subs. Okay, they are substituents to a chain. Okay, you have a bigger chain, but these 3 carbons are just subs to it. Now, if you are joining into your bigger chain through the first carbon, then that's the normal propyl. But if you're joining into your bigger chain through this middle carbon, then we say you are having the isopropyl. So isopropyl, it is the position. It's all about which position. If you join to your bigger carbon through the first position, you are N. That's the normal. You're just doing. So first could be this one or that one. If we are joining into the bigger chain, okay, that normal chain, the main chain with the R with the first carbon, then it's okay. But if we are joining into the main chain with the middle carbon, that is where we form the isopropyl. So remember that the propyl has 2 forms. Sorry for this guy who is disturbing us. Okay, I've removed them. All right, so now we have the isopropyl. So they've told us we have isopropyl, so that means we are joining through the middle carbon, okay, of our 3 things. There'll be three, okay? Now, when we start, let's start with this guy. We start with the main guy, methyl nonane, okay? Nonane, that's an alkane, right? Nonane has 9 of them, 9 carbons in the chain. So let's go. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So here is your nonane. And here he is a 4-methyl. Okay, so we're going to count 1, 2, 3, 4. And in here on the 4, we put a methyl, which is a CH3. Okay, that's a methyl. Meth is for 1 carbon, right? You can check the list. And then now we have 5 isopropyl. So this is 4-methyl. Then on position 5, we will have an isopropyl. So we have a propyl, but it's connected through the middle carbon. So that's what makes it an isopropyl. It's like this, okay? So in here, we can put it as this would be a CH3, and this would be a CH3, okay? Then you could have it like this. So if you want to put it, this would be a, let's fix, this would be a CH3. Then this one, since it's inside, it would be a CH2, okay? Yet this would be a CH2 again. Then this would be a CH, since it has 3 bonds, okay? This would be a CH like that, okay? Then here, this again would be a CH, okay? Then here, this one would be a CH2. Here you have a CH2. Here you have a CH2. And here you have a CH3. So we write a CH3. It's the final thing. And you are done. This is going to be your 5 isopropyl 4-methyl nonane. I hope you understand it. Okay, we started with nonane. Then on position 4, on carbon number 1, 2, 3, 4, we just started counting from the left. You can start counting from the right. We put the methyl on number 5, on carbon number 5. Remember, it's going to a carbon. So on carbon number 5, that's where we put our isopropyl. Remember, it is a propyl, but just being connected. This is a CH, and then here we have a CH3. Just being connected through the middle carbon, we call it an isopropyl. Now we go to part B. Part B says we have a p-methylphenol. So P is for para. I want you guys to understand that. When we have something that is cyclic, okay, like a phenol, we could have it like this. Let's show it. Something like this. Then we have it like that. So what I want you guys to understand is when we have this, if we put our OH, pheno means we have a benzene ring like this and then OH attached. The position where the OH is what we'll start calling position 1. Okay, and then this could be position 2 or this one, depending on which way you're going, anti or clockwise. It doesn't matter. Now, if you put on something on position 2, let's say you come to position 2 and put a CH3 there. Okay, now you are having things substituted on position 1 and 3. Okay, on position 3, that's where your methyl is. So you can just call this a, for 1 and 2, 1 and position 2, sorry, for position 1 and 2, we use the word ortho. So you can say this is an O, and then you say methyl, then methyl pheno, okay, for O. Now, if we put our methyl on position 3, and it now becomes 1, 3, okay? So let's put it again. It now becomes 1, 3. Here we put our CH3, right? On position number 3. Then here it becomes meta, which starts with a small m. So we say meta methyl pheno. Okay, so that means the methyl we now know is on position 3 because pheno will be our position 1. And for us to get meta, this is ortho and this is meta. It will be on position 1 and 3. Then the last one would be position 1 and 4 here. Okay, position 1 and 4. If I come and put my CH3 here, it's now on position 1 and position 4. We'll use para. It is now para. We will use a P. So P methyl pheno. And I've already done it for you. Okay, so that's the P methyl pheno. It is on position 1 and position 4. Don't forget, it's ortho, meta, para. Okay, ortho is for position. Let me change my eraser, make it small, remove. Ortho is for position 1 and 2, meta position 1 and 3, then para position 1 and position 4. And that is what you are going to have. And this is it. Okay, this is it. Number B. And then we can go to number C. Number C says we have a Z. Remember Z, it is one when we say Z, same side. Okay, Z, same side. So that means they are going to be on the same side. What? The priority groups, the priority guys. Okay, the guys with the high weight. They're going to be on the same side of your double bond. Let's see. So what are we going to have? We start with this guy on the right. It's pent 2 in, then 1 O. So let's start with pent 2 in. It's going to be 5 guys for pent. So 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. And on carbon number 2 and carbon number 3, that's where we have our double bond. Because if I put my double bond on carbon number 1 and number 2, we will use 1. So we'll call it pent 1 in because we always use the smaller number. So for us to have pent 2 in, it will be on 2 and 3. Then we take the smaller number, it will be 2. So it will be pent 2 in. That is where it is. And we have 1 O. So on position number 1, we have an OH because it's a 1 O. Then what do we have? 3 methyl. Okay, so on carbon number 3, we have a methyl group there. So either it is at the top or at the bottom. I'm not sure yet. Then what else do we have? 2 chloro. On carbon number 2, we have a chloro here. So it's Cl. And then we are done. So now they said it is Z. So remember, if it is Z, that means the guys are on the same side. So the priority guys. So let's put, here would put our dotted line. That's a bad crayon. I'm going to take blue. Here would put our dotted line going through the double bond. Now, if we see who is going to be there on, here's our double bond. Remember that we are analyzing. Let me help you analyze. We are analyzing this carbon over here in blue and this one here. These are the carbons that we are analyzing, right? So let's analyze them. We see this carbon on position number 3, right? This carbon. What is he bonded to on top? He is bonded to a CH3. Then here, the other thing is bonded to is this becomes a CH2 and this is a CH3. So what just happens is when we are putting this, okay, so we know that in here, you could say this is a CH, okay, makes it 4 bonds, and then it's like this. No, it's just a C. It's just a C, and then this is the CH3. So now what happens is, this thing is coming back again. Really? Okay, we've taken it away. So now what really happens is, for this, we want to see if it's a Z or it doesn't. So first thing we said, what do you test? You're going to test if the two guys connected to this carbon are different, and we've seen that they are different. And then the next thing you're going to check is if the two guys, okay, connected to this carbon are different, and you see that they are different. So fine. Now the next thing is for E or Z is we are done. Now we just need to know if it's E or Z. So who's going to be heavier? Let's look on this carbon, which is on the right. It's connected to chlorine, then carbon. And chlorine is heavier, so that means chlorine is what we use. And then on the other one, it is connected to CH2 and CH3. And we said that when it is connected to a CH2 and a CH3, you always go for the carbon that is connected to more carbons. So it's going to be this guy. He's going to be connected to more. So that means if I come from below to this guy, which is below, we are on the same side of the dotted line. Can you see? If we put a dotted line, these two are at the top of the dotted line, and then these two are at the bottom. So it's a Z. So it's okay like what it is right now. Okay, what it is right now, everything is okay. And that is what happens. Okay, so don't forget that. Okay, this is for Z same side, and that is the guy which you are looking for. And let's see if I put him correctly. This is a CH3. 1 2 3 4 5. Okay, and that's the end, and you are done. Okay, now we'll do part D and E now, and then we'll call it quits. Part D says 3-methyl whatever. So we start with the last part, which is pentanal. So what do we know about it? We know it's an aldehyde because it's ending with an now, and it's pentanal, so it has 5 carbons. So 1, then 2, then 3, then 4, then 5. And here you have your CH3, blah, blah, blah. Let's first put the guys that we had to put here. We have a 3-methyl 4-oxo. So when you see the word oxo, it means it's a carbon with a double bond and O, double bond O. So on position number 4, we have an oxo. So 1, 1, 2, 3, 4 on oxo. Then we are going to have it. Okay, so this is oxopentanal, and because it's pentanal, it's an aldehyde. On the last carbon, we need to put a double bond O, and then we need to connect it with an H, like this. That makes this an aldehyde, so it's pentanal. Then if we put the 4-oxo, then 3-methyl, so that means on number 3, what are we going to have? Methyl group. So we could even put it going down to say methyl. So that is what happens here, and that is what should be having. On position number 3, you have a methyl, which you can put it as a CH3, okay? CH3. Right? And that's what happens. 3-methyl, 4-oxo, and then we have your pentanal, okay? Pentanal, that is it. That's going to be the end of it. Okay, now part E, remember we start counting from the aldehyde group here for pentanal because it's an aldehyde. Then for part, the last thing which we do is we are doing this number E. We have cyclohexanamine. So it's an amine, and this is what it looks like. Cyclo, 1, 2, 3, 4, and then 5, then 6, something like this. But now you don't have the benzene ring structure inside, either like this or like this. We don't have it. So basically what it is like, when we are in 5, we have the cyclohexanamine. So the amine is going to be there here, NH2. Well, we can start with just the N. We'll see how many hydrogens to put. Now here, what do we have in the cyclohexanamine? We are going to have N-methyl, okay? So here we are going to have methyl CH3 connected to the N. When you seeing N-methyl, it means it's connected to the N. Then we have N-ethyl. So we have an ethyl, which is 2 hydrogens. So it's going to be an ethyl is two alkyls, so it's going to be here CH3, then CH2. Okay, we can just say CH3 CH2. And this is what we have when we have the thing, the N-ethyl, so ethyl, two guys, and then N-methyl, then cyclohexanamine. And that's it, and you are done.